Welcome to the DIY Honda Garage channel. The DTC P0139 indicates an issue with the secondary heated oxygen sensor, also referred to as sensor 2. This sensor measures the oxygen content in the exhaust gases after the catalytic converter, helping the engine control module, ECM, adjust the air-fuel mixture for optimum efficiency and emissions control. A slow response from this sensor may signal that it is failing to provide accurate information to the ECM, potentially affecting vehicle performance and emissions. The failure mode typically occurs during conditions where the throttle valve is closed and the air-fuel ratio is lean. It is critical to address this code promptly, as it can lead to increased emissions and reduced fuel efficiency. Additionally, any leaks in the exhaust system can false trigger this code, so a thorough inspection is vital. The DTC P0139 refers to a malfunction in the secondary heated oxygen sensor, known as sensor 2, which is positioned after the catalytic converter. The primary role of the secondary HO2S is to monitor the exhaust gases, helping to ensure optimal fuel efficiency and lower emissions. If the HO2S reports inaccurate data, the engine control module, ECM, may struggle to maintain the ideal air-fuel ratio, leading to performance issues. Under specific circumstances, such as a closed throttle valve during a lean air-fuel ratio, the ECM regulates the closed-loop system based on signals from the HO2S. If the signal voltage from this sensor does not align with expected responses, P0139 is triggered, flagging a slow response. Effective functioning of this sensor is crucial for minimizing pollutants being emitted from the vehicle. There are several potential causes for the DTC P0139 being set, primarily focusing on the secondary heated oxygen sensor's integrity and its surroundings. First, a faulty secondary HO2S itself can lead to incorrect voltage readings, signaling a slow response to the ECM. This can arise from age or environmental exposure, degrading its performance over time. Another critical source of error stems from leaks in the exhaust system. When there are exhaust leaks, they can skew the readings from the sensor, leading to abnormal sensor behavior. A third possibility is related to the wiring and connectors associated with the secondary HO2S. Damage, corrosion, or disconnections in these components can hinder the signal from being transmitted efficiently to the ECM. It is vital to diagnose these issues methodically to repair the root cause accurately. The symptoms associated with DTC P0139 can vary, but typically manifest in a few key areas. One of the most noticeable symptoms is an increase in vehicle emissions, which could lead to failing emissions tests. This occurs because the air-fuel mix is not being corrected optimally due to faulty sensor readings. Additionally, drivers might experience poor engine performance, characterized by rough idling, hesitation during acceleration, or reduced fuel efficiency. This is a direct result of the ECM being unable to make timely adjustments to the air-fuel mixture. Of course, one of the primary indicators that something is wrong is the illumination of the check engine light on the dashboard. Each of these symptoms underscores the necessity for timely diagnosis and repair to restore vehicle function and compliance with emissions regulations. The first step in troubleshooting DTC P0139 involves starting the vehicle's engine and holding the engine speed at 3,000 RPM. This should be done without any load, which means the vehicle should be in either park, P, or neutral, N. Keeping the engine at this RPM is crucial, as it ensures the vehicle is operating within a specific range that is necessary for monitoring multiple parameters related to the oxygen sensor. While maintaining this speed, one must wait until the radiator fan activates, indicating that engine cooling is effectively functioning. This step prepares the system for the next phase of diagnostics by ensuring that all preliminary conditions are favorable for testing the sensor 2 functionality accurately. Following the initial step, the next phase requires letting the engine idle after the radiator fan has activated. This is essential for establishing a baseline when monitoring the outputs from the secondary heated oxygen sensor. Next, a test drive is mandated under specific conditions. During this drive, it should be ensured that the engine coolant temperature, ECT sensor 1, is above 158 degrees Fahrenheit, 70 degrees Celsius, to provide appropriate operating conditions. While driving, it's vital to maintain a steady speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour, for at least a minute. A crucial aspect of this is then decelerating with the throttle fully closed for 10 seconds or longer. Throughout this process, monitoring the Honda Diagnostic System, HDS, for the appearance of DTC P0139 will provide insight into whether the sensor is responding correctly, or if faults are found indicating further investigation is needed. Upon completion of the troubleshooting and any necessary repairs pertaining to DTC P0139, it's crucial to verify that the repair was successful. The first step involves confirming that the diagnostic trouble code, DTC, has been cleared from the system. This can be done using the Honda Diagnostic System, HDS, which allows for easy monitoring of current codes and statuses. Following the clearing of the DTC, confirming that the secondary heated oxygen sensor is functioning properly is essential. This could involve observing real-time data from the HDS to ensure that the sensor's voltage readings align with expected patterns. Lastly, it's important to perform a road test to validate that vehicle performance has returned to normal and that no new DTCs appear. Ensuring these steps are followed will guarantee that the underlying issue has been resolved effectively. Preventive maintenance is invaluable in ensuring that issues like DTC P0139 do not recur. Regular inspections of the exhaust system are paramount, as undetected leaks can lead to sensor malfunctions. During these inspections, it's advisable to check the integrity of all parts of the exhaust system, including pipes and connections, to ensure there are no signs of wear or damage. Additionally, routine checks of the oxygen sensors, including the secondary HO2S, should be integrated into regular servicing schedules to catch potential malfunctions early on. Another aspect to consider is driving habits. Excessive idling or frequent short trips may contribute to premature wear on the sensors. By considering these preventive measures, vehicle owners can mitigate the risk of future DTCs and maintain optimal vehicle performance. In conclusion, the DTC P0139 signals issues related to the secondary heated oxygen sensor, affecting vehicle emissions and performance. A detailed understanding of the sensor's role in regulating the air-fuel mixture is essential for effective repairs. It's critical that the troubleshooting process is followed systematically to ensure that all potential causes are adequately addressed. Regular maintenance and inspections can prevent many issues related to the HO2S, ultimately safeguarding the vehicle's performance and compliance with emission standards. By being proactive, drivers can extend the life of their vehicle components and promote efficient driving practices, leading to better fuel economy and lower emissions over time. Always remember that comprehensive diagnostics are vital for pinpointing issues accurately, thus preventing unnecessary repairs. Please like and subscribe to the channel. See you next time.